I think people are quite excited, Surya. Yeah,
Sorry?
I think people are quite excited. They keep coming in.
Yeah, I don't know. Should we start?
Let's give them a minute.
Yeah, let's give it a minute. Should find A. All right, I guess we should get started. Yeah, you guys ready?
Yep.
Great, we're fun.
Yep, all good.
All right. Good evening, everyone, and welcome to the second session of our .NET Diaries. Today we're going to be talking about a personal favorite. We're going to be talking about the cloud and how well .NET integrates with it. My name is Surya, and I work as an associate tech lead here at Capstars. And we're joined by two experts on .NET and cloud computing. For those of you who joined our previous session, you would remember Rifan. He is a co-founder and also a tech lead at Causit. We also have a new speaker, Lankita, and he works as a technical lead here at Capstars. I'd like to give them the opportunity to introduce themselves.
All right, so maybe I can go first. Hi, everyone. I'm Rifan. Probably the ones that who joined the last session know me from there. I am a technical lead and also a co-founder at Causit. Yeah, so I love all things .NET, like you would have known if you were there at the last session. Apart from .NET and work, I do follow F1, but it's a bit boring these days with dominance. Yeah, end it there. Over to you, Lankita.
Yeah, okay, thank you. Hey guys, I'm Lankita Garlake, a decade in the .NET world and currently working as a technical lead at Capstars. Let's say I've seen more lines of code than I had cups of coffee. Excited to be here, share some .NET tales, and maybe pick up a few tricks.
Thank you so much. Thank you so much for being here and sharing your experience and views. We really, really appreciate it. I'm sure we're all going to learn something. Just to put it up front, there is no fixed agenda. Like I mentioned, we're just going to be talking about building cloud applications with .NET. We do have this platform called Slido where you can drop your questions, and I'm sure Lankita, Rifan, and myself would be more than happy to answer them after the session. You simply need to scan the QR code and drop your question. I guess they might ask for a code, and if they do, that's the code. You don't have to do it right now. We will be repeating the slide at the end of the session as well. So I'm just going to give you a minute in case you want to scan that, and then we'll jump into it. Yep. I think it's okay. We'll be repeating it, so should be fine, right? Let's get started. All right. Before we let our amazing speakers get into it, I'm just going to give you a quick, just clear out a few things, right? Just because something is new and shiny doesn't mean it will work for you. Sometimes it might not be the best solution. Think about the cloud. Just because you lift and shift your application into the cloud and say, hey, you know, we have a cloud-based application. It might not always work. Sometimes you might end up spending more money, or it might not actually give you any benefit. That's why the shift should, in my opinion, have some business goals, like achieve something, be it cost saving, easy to scale, elasticity. And I think the guys are going to cover all cool concepts in the session, but I just want to emphasize the why. Why is it important? Why are you making that shift? Why are you moving to the cloud? Once you've defined the why, I think then you move on to the how. So the approach you take might have significant implications. For example, if you want an application to be very high performing or resilient, you might take a cloud native approach. There you focus on the capabilities of the underlying cloud platform. But say you want your application to be more flexible or portable, then you might take a cloud agnostic approach because it doesn't really matter, right? But you know, you can always switch things up later. You can re-architect it, but it's good to have a think all these things up front as well, especially if you're building a new application. And then I think your process is more seamless. Because this is a .NET talk, we're going to plug in .NET, right? If you haven't checked out our previous session, it was on the .NET evolution. And that's quite important. So if you haven't, please do check it out, but I'm just going to give you a quick recap. Because of the evolution of .NET, the ecosystem is such that building cloud applications super simple. We had the .NET framework before, and it was a kitchen sink approach. It was everything in a box. It worked. Everything was turned on by default. It was also Windows specific, and that was fine at the time. But if you're thinking cloud, that's a bit, that's not the best solution, right? It's limited. So 2016, we have .NET Core. So .NET Core, in my opinion, was a game changer. Why? Because it's cross-platform, it's open source, it's modular, it's container friendly, and it's all this cool stuff. I think it was built with the cloud in mind. It also has, just about the framework, it has really cool tooling. It has impressive libraries. It has a really cool logging abstraction built into the framework. And I'm sure you'll understand why logging is super important when it comes to the cloud in the session to follow. But yeah, it had all these amazing things. And then now we have .NET 7. And then in November, we're going to see .NET 8, right? So the point I'm trying to make is, as time progresses and as the ecosystem evolves, building cloud applications become really seamless. And I don't see why not. I don't see why we don't use .NET to do it. But yeah, enough from me. I'm going to let Lankin and Fran take over. Maybe we can just discuss a few cloud characteristics, or yeah, something that makes sense.
Okay, let's quickly chat about the the magic behind the cloud computing. The first thing is the on-demand self-service. Imagine having a power to grab what you need when you need it, and need some storage or computational power. Just reach it out. It's required actually. And the second one is the broad network access. You are never too far away from the cloud, whether you are on your phone, a tablet, or laptop. The cloud is with you as long as you got the internet. And the third one is resource pooling. Think of the cloud as a massive pool party where resources are shared. No one reserved any special spot. It's just about all coming together. And the fourth one is rapid elasticity. Just like an elastic band, the cloud stretches based on your needs. Whether you need a little or a lot, it's just on the fly actually. And lastly, the measured services. The cloud got a watchful eye. Everything is tracked, optimized, and reported. Ensure both you and the provider know what's going behind the scene. So there you have it. It's the cloud computing in a heartbeat.
Thank you. I think that was quite nice, sweet and short, basic just basic overview of the cloud, right? Now, speaking of .NET, I know tooling is something that's quite important. I mean, from a developer's point of view, can we just discuss like what are the tooling that enables us to build really great cloud applications?
Okay, let's just explore the essential tools for .NET developers. Actually, I have divided the .NET tools into 10 main sections. Starting with .NET IDEs, we all have our favorites: Visual Studio, Visual Code, JetBrains Rider. Some of the topics, actually. For those who love the command line, .NET CLI is indispensable asset. It streamlines our tasks from creation to deployment, actually. And talking about the version control system, the JIT comes into play. It's the backbone of all collaborations, and the .NET does support it. And every .NET developer knows the value of the package managers. With .NET, not only we can leverage community packages, but we also can create and publish our own Nugget packages we can share within our team or with the .NET community. And no development is complete without the debugging, actually. With the tools integrated with the IDEs like Visual Studio and additional libraries like nlog and Serilog, actually the debugging becomes really easy. And also we have to talk about the testing tools such as NUnit and Selenium. Next, we have to talk about the build tools, CI/CD solutions in .NET, actually. The MS Build and Azure Pipeline stand out for creating a smooth CI/CD pipeline for development to deployment. To ensure code remains top-notch, we have a code quality and analysis tools like StyleCorp, ReSharper are notable mentions in that area. And again, the data is the heart of all the application. Database tools like Entity Framework Core and SQL Server Management Studio are provided by .NET to manage the data and preserve whatever you need on the go. Lastly, in the cloud, development tools from providers like Azure and AWS, deploying and managing .NET applications in the cloud become really easy. So that's about it. That's the tools we have in the .NET. I think I have covered most of them.
Yeah, just to add a few there, I think .NET CLI is quite powerful with extended features like .NET Monitor, where you could monitor the meters that you push in your application and so on. So like debugging, really with .NET CLI, what has happened is we can now depend very less on Visual Studio and move to other code editors. Yeah, it's a really powerful tool.
Yep.
Yeah, I agree. I always get shade using .NET CLI. And they're like, why? But I think it's really cool, right? You can do so much.
Absolutely.
Nice. Thank you. So I guess what we've established is using .NET. I mean, we have all this tooling around building applications. So it's your preference. You have options, and it's great, right? So speaking about cloud, I think the first thing that comes to my mind when I think cloud is scalability. That's the beauty of it, right? So should we just jump into the concept?
Yeah, so when you talk about scalability, there's two distinct approaches that you can take to scale. One is vertical scaling or scaling up, and the other is horizontal scaling or scaling out. Essentially, with vertical scaling, what you do is you keep your application as is. So if you're running .NET, of course, since we're talking .NET here, you would just keep your application as it is and just add to it infrastructure resources like memory and CPU. But the problem with that is at some point you're going to hit the roof and you can't really, scale up always. Scaling out, essentially, there is a bit of changes that you need to do to your application. It should be stateless, and then mainly stateless, because now what you're going to do is you're going to have multiple instances of application running horizontally in different infrastructures. One thing you need to do there is you need to bring in reverse proxy, API gateway, something in front that's able to orchestrate all the requests. The advantage here is in terms of resilience. If one of your instances fail or due to some request something happens, that's all right. You have a couple of more instances that can actually serve your users. So that's the two options for scaling.
But I think Rifan is vertical scaling is much easier compared to horizontal scaling. So obviously you're going to hit a limit, but when it's come to the start of the development, the vertical scaling, I think it's the one most people go for.
Absolutely. I think you need to build your applications that it's able to scale out. So if you look at .NET, you have so many APIs that comes with .NET, and so many more coming with .NET 8 that allows you to build cloud-native applications with stateless auth and different providers for state management, and if you want a caching solution and all of that. Like everything is really simple. Even managing your secrets, it's really options are diverse with .NET. So you need to build your application that's able to scale out. But I agree with Lankita. You need to focus on building an application that can run really well vertically, and then think about scaling out. So keeping it simple and stupid at the start before just going with shiny things. I know I might sharing in a very unpopular opinion here, but I'm not such a fan of when you start off an application to directly go and go ahead and use Kubernetes or something like that, because I think you need to first understand the capacity of the application. You need to do some sort of capacity planning just to understand what scale you're working with, and depending on that, use whatever the services that you want to. Most of the applications will just run fine on app service.
Nice, I agree, but also I agree with you, but I also feel that, the beauty of the cloud is horizontal scaling, and it doesn't have to be like, it's on demand basis, right?
Yeah.
But then you're right. It is your first and foremost, it depends on your requirement and where you are at your stage. And you don't switch around, right? Sorry,
yeah, when you go to the horizontal scaling, there's so much of things that you need to concern about the orchestration and a lot of things in the code. The maintenance become really complicated, so you have to do more time, put more time into the maintenance. I think it's better to start with the basics. Like always say, keep it simple. Always.
Agreed. So, okay, cool. So we understand the concept of scalability. Maybe we can discuss some scaling models in .NET. I know there's so many, and we don't have the time to go through everything, but probably the most important or few of the most important ones.
Yeah, talking about the scaling models, there are a lot in .NET Cloud, basically the Azure Cloud. So one of the things that we have to talk about is serverless computing, and there are a lot because the time concern. I don't think we can cover every single one of them. Maybe we can do it another session later. So what is serverless computing? It's not about getting rid of servers. It's more like giving the developers the superpower. Imagine having an entire infrastructure ready to go where you can just jump in code and deploy without getting into too much of concerns about the configurations. We had a platform as a service for a while. Well, I think the serverless is at its cooler version. And serverless, you only pay for what you use. The app's just hanging out or doing nothing. For that, you don't have to pay for that actually. So what's the big deal with the serverless? It's simple. It lets developers to do what they do best, build awesome stuff, no more jiggling configurations, patches, so nothing backend mess. You write the code, and the serverless platform handles all the heavy lifting. So it's like having a backstage crew that sets everything up for you, and you just go on the stage and rock. And talking about the serverless, for the serverless, we came quite a long way. starting with the bare metal servers. So they were hosted in-house or in another client server or online. So we had to maintain them by ourselves. Then after that era, the virtual machines came. Then things become quite easy. But for the virtual machines also, we have to install the OS and install the patches and take care of the security risks and everything. And then the era of the containers come, there things became really awesome. You can just write anything and put into a container and put it to a server that with orchestration, and it will do whatever it should do to maintain the application running in different instances. That was actually really cool. So after that, the serverless era came. So I think it's a collaboration of all the concepts that we had earlier. So there are a couple of big players in serverless arena like Microsoft Azure, AWS Lambda, Google Cloud Firebase, Oracle Functions. And when you're talking about the advantages of serverless computing, you need to pay for only what those resources you use. There is no need to manage the servers and pay extra cost for their maintenance. It provides dynamic scalability, which is quite really important. It provides quick deployments and constant updates. They do update by themselves. It promises very low latency as the code runs in the nearest region, close to the end user. Actually, so we can just pick the region what we need to run the code in, so it will just run there. The latency will be really, really low.
That's really cool. I think something I heard and I just wanted to say it out. Like when they say serverless, it doesn't mean no servers. It means think of servers less, which is really cool because at the end of the day, everything in the background is a virtual machine, right? It's just that you don't have to worry about it. You just focus on the more important stuff, which I think is pretty cool.
Yeah. Just to, I think one of the challenges we had initially, I think we still do have with us for a while now, is cold starts. So when you scale down to zero, sometimes it takes some time to function to come alive, and that might have some latency. So some of the solutions that were put in was like just pinging and keeping it alive and so on. I'm not sure what's in these days, but with native AOT support coming in .NET 8, I think it's going to be a huge win for serverless in .NET.
Yeah, super excited for that too.
Yeah, so I think we have, what this would look like in a real world scenario, like a serverless architecture. Is there anything that, that's worth pointing out here?
Yeah, so this structure is basically explaining how the serverless is working. So there can be triggers. So trigger can be event in Event Hub or the service bus or a webhook GitHub like HTTP or HTTPS request, anything. So whatever it can be called for a function, that is a trigger. So after a trigger being executed, the function will execute. Function will wake up and execute and send the messages to either a cloud messaging service or a cloud storage service. So from there, you will just can read the message or send back the message to as an alert to the end user. So that's it. That's the so this is very, very oversimplified version that I put it in the slide, Surisha. So it's a bit complicated, though. But this explains how the service is working. So it's just you don't have to worry about the service, like you said. You just have to worry about sending the messages and just receiving them.
But sometimes it's scary when you look at this, so many moving components.
Yeah, and also it comes with a kind of set of challenges as well. I think we have already addressed this in the last few years, the cold start of the functions. And I think that state management is not possible, and the complexity is really high. And And when you develop it locally and test it locally, it's really complicated. And the monitoring and debugging is also complicated somewhat, but we can use other resources in cloud to overcome that. And also another thing, we cannot predict the cost. The cost is always depending on the how many requests it is being received. And another one is there can be long-running processes. We might not know if we don't program correctly. We might never know what's going behind, and we might never receive an answer.
Yes, I'm hearing a lot of complexities, right? You don't know what happens, you don't know what breaks, which server throws an error. So I think another very important concept, and it's something I mentioned earlier about logging, but it is observability. We need to be able to monitor what's happening in, with our application. So I think that's something that we need to touch base on.
Yeah, absolutely. So when it comes to observability, I think I forgot to highlight the three main pillars in observability. It's metrics, logs, and tracing. So basically logs with .NET, you could ship logs in the W3 standard, W3C standard. So certain standard that's understood across using, basically logs. Everyone who's worked with .NET, you probably have injected iLogger into your classes. So you know what logs are. You can ship them to any storage. In here, we have application insights, but you can ship it to any storage. And metrics can be derived two forms. One is through your logs. So you can run filters on your logs and collect metrics. So metrics are measurements like, your response time, your gRPC call latencies, or even custom metrics you can ship from within your application, maybe something specific to your domain, like transaction times or something like that, very application. So you can derive those and present it in a dashboard so you can look at. And having logs and metrics doesn't mean anything if you don't respond to issues, right? So as devs, you can't be just a page on Datadog or Neuralink or any of those platforms or CloudWatch or any of the platforms looking for errors. So you need them close to you, to your working environment, which is the communication tools that you use, like Slack, Teams. So you run filters, create the logs, and here you set certain thresholds on your metrics to say, you exceed thresholds, you spit errors to the platforms that you use. This is the basic concept around observability, but then with the practice of SRE and stuff, there's a lot of things that have come in with, SLIs, SLOs, and error budgets and different terminologies. I think that's out of the scope of this today. But really, really interesting stuff that's happening in terms of process and tooling.
Yeah, I
want to add something on top of that. Since we have a cool application inside, we don't have to overuse it. But something I've seen over the years is like people are dumping every single thing into the log, so it will be really complicated to fetch something or filter something. It's like millions and millions of unwanted things inside the application. And also something when we post something into the logs, it doesn't mean that though it is in a queue, it is inserting as how it is in the queue. So we have to include most of the things what we need inside a single message, so that message can be properly extracted into a correct object and just do the metrics afterwards. I think, Irfan, you can explain.
Yeah, so basically the logs that you look at is not the correct representation of the chronological order of where the application executes, because you can't guarantee that. The execution order and the log might be different. So you need to have some context. I think we'll speak more about it down the line, but you need to have in some context, and you need to be able to, it's like Lankita said, you need to confine all the things that you require for debugging in one single log message. So it's easier. Yeah. And using log levels is quite important. Understanding what should be an information log, what should be an error log, what should be a debug log, so you can turn on and off those log levels so that it does not pollute your logs and your errors don't get lost inside all of those logs that you have.
I know, I like, alerts, super cool. But I remember waking up every day hoping that I don't have a Slack notification. It's like, oh, I hope something didn't break. It's cool that we have it, but yeah. Also, I know that you mentioned, Rifan, you mentioned about distributed tracing as a third important point. And maybe we can dive deep into that.
Yes, there was just a comment from someone that says structured logging. Yeah, so the W3 logger, the W3C logger it's a middleware that logs in the W3C standard. So it's a certain standard that's on. Yeah. Yeah. So distributed tracing, I did mention about this. Yes, this is also one of the main pillars when it comes to observability. In the core, like the basic of it is if you, with microservices coming in, if you have an architecture like this, have an API or some reverse proxy at the front, and then you have multiple services and you have inter-service communication. Again, when there is an error, it's so difficult to know which service failed and able to really capture that information. At the core of it, you need to have some type of context that passes passed around, and you're able to aggregate and filter and then look at the entire story.
Interesting. All right. So, but there is a lot of complexity around it, right? How do we manage such complexities? I know there's a slide on cool new thing, but yeah.
Yeah, there is so many ways you could manage complexity. This is just one way. So Dapper is just an abstraction that abstracts out all of the components that you would need when you go cloud native, or you, depending on what you use. So in service communication, state management, observability, and so on. The good thing about this is it abstracts the complexity around understanding the SDKs and the different APIs. And it just opens up an HTTP or a gRPC API, and it's programming language agnostic. And it's built on top of something called building blocks. So if you find that there is a missing building block, it's open source. You can go and contribute and build on top of it. But this is just one way, and of course, depends on what application you use. Yeah.
I like that. Do you have any thoughts on managing complexity? Observability, or we can, yep.
Yeah, we can. I think Rifan covered pretty much everything of the managing complexity. Like I want to add one thing. So I remember like early days, like 5-6 years ago, when it was the microservices were popular in our region. So people wanted to start everything with a microservice. So I've seen a lot of projects that gone messed up in the middle while they were trying to start with the microservice, not convert the earlier version of the application. So I prefer it's like for to be in a microservice architecture, your application should be in a really mature state. You have to have really lot set of data, and you should know how the application works, that the bugs should be known, and or the maintenance should be keep doing for the application. If we go on that, so I think the microservices can be used for the applications.
Yeah, I agree. It's a classic example, right? Like, I mean, it's based on your requirement. If a monolith works, it works, right? In the beginning, it was just like, oh yeah, microservice, it's new, let everyone jump on the bandwagon, but it doesn't really work for everyone. Yeah, I think you need to focus on what is your need of the hour and then build accordingly.
Absolutely. This is just one thing out there.
Yeah, there's a saying that if it is working, don't ever touch it.
Yeah, but then also you lose out on a few capabilities, right?
Yes, a lot of complexity is covered.
It's true. All right, so I think we've covered, the observability part. We've covered scalability. Another really important thing is security. And I know .NET handles this really well. So maybe we can dive into that.
Yeah. When we talk about security, there's a lot, but then we focus on identity so that we cover the spectrum of building a cloud native application in .NET. When it comes to identity, it's very important because you need to secure application for your users. Essentially, the different approaches you can take in .NET. So if you want, you could build your own identity solution with SP.2 identity. Basically, you could use the APIs that is given, and if you would like to manage your users, user passwords, and so on, you could do it. And it's not rocket science, so the documentation is out there. It's quite easy. You can even work with policies and so on. And the other approach is going with third parties. There's two distinct ways you can approach it. The first is using Microsoft Identity. So Azure AD, Azure B2C, or Azure B2B. B2B only if you want to, add users from external tenants. So you can add them as guest users, and they can log in as guests into your application. So if you have that requirement, you can go with Microsoft Identity. The best part here is with the MSA library. The integration in the front-end frameworks are really easy. So that's one part with Microsoft Identity. Of course, then you're a bit tied down to Microsoft there. And the third option is, of course, again, using any of the open source or any other identity providers that you like Keycloak, which is a really good one. Comes with, you can host it with Docker and then connect it to a Postgres DB, and it works perfectly well. Works well with all the standard protocols, authorization code flow, Pixie, or anything that you want. And yeah, so these are the three options. There is some exciting news. I think we'll talk at the end with .NET 8 here, but then yeah, this is what you have as of now with .NET 7.
It's pretty cool. I know I've personally used Keycloak, and it's great. It also is good if you go in the cloud agnostic approach, because tied to Microsoft. That being said, Azure AD is pretty easy to set up, right? Is there any complexity around building your own? I mean, is there any cost savings, or as say I want to build a new application, a small application or a POC? What do you think would be a good approach to just like get something started?
I think using one of the third parties, Keycloak is also quite easy. The other thing is, I think you'll have to host. So if you want, you can connect, use Microsoft Identity, or even building your own one is not too complex. So you connect it. You connect it. I think by default, what it gives you is it gives you the option to connect to SQL Server in EF4. But of course, you can extend to use a different ORM or a different storage provider depending on what you want. So they're totally extendable. Yeah. I personally prefer third party because then it's built with all the security audits and all the testing done properly, so you don't have to really worry too much. But it's simple POC application. We build your own.
Okay, so yeah, it's just like the benefits of the cloud, right? Like someone else manages it, and you just get to have things out of the box. So.
And also, Surya, when it comes to custom applications, so we can't use most of the time we can't use the entire thing in the box. We have to cut it into pieces and build it our own structure. If we go into multiple authentications with the different providers, we can also go for a hybrid solution using the .NET identity services.
Okay, that's an option. You can. Okay, that's pretty cool. Sorry. Okay, so I think we've covered identity, but when we're talking cloud, there's so many concepts, and we generally don't have the time to cover everything now in the session. But for sure, there are going to be more sessions that we're going to, I think, possibly dive into one topic and go into all the details. But I think for like the final leg of this session, I mean, it's something cool, right? We should talk about it. So .NET 8 is coming in November, and I know there's like a lot of cool stuff around it. So we can probably just like maybe mention a few things that you guys are really looking forward to.
Absolutely. I think for me, like I mentioned, the standout is out of the box auth. So zero dependency auth setup right out of the box with .NET 8. You have an implementation of Identity Manager with SQL Server and EF2, of course, that you can use. And there's even a UI for user management that comes out .NET 8. So that's really cool. Quite excited for it. And this should be really easy to get started with building simple applications, Surya. So possibly answers your previous question. Just go with what's there out of the box for a really simple one. And then you can move to a third party when the scenarios are complex, when you have third party integrations happening, when you want third party organization users to log into your application. And when you have all of the complex scenarios that come in, you can go with Microsoft Identity probably. Or with other provider, yeah, if you like.
Nice.
Yeah, a couple of new features they also added in the CLI, like .NET Publish and .NET Pack. I think the CLI users will be more excited when they hear the story. And I think another one that I really should want to mention is the serialization on the new .NET version. Like before, like there's a marathon between JSON serialization for the native and the Microsoft JSON. I think pretty much everyone knows the Microsoft one. I think the native is trying to compete with it because there are a couple of gaps when you try to use the native with your applications. I think let's see what's in the .NET Preview 1 coming in November. They might have some cool features for the serialization.
Yeah, definitely look forward to that. Sorry, Irfan.
Yes, absolutely. And native AOT is something that we cannot forget. I think huge performance improvements in startup times and so on. Again, like I said previously, it's going to help with Silverstone.
And also, Irfan, they have mentioned in the preview one, they have reduced the size of the application into almost half when you publish the application. I think that might be quite exciting, right?
Yeah, I know, like that's what they've always been striving for, right? They try to reduce the size of the application because quite wealthy. But
because
yeah,
of the AOT, because they have introduced in .NET 7 and they keep improving it. They want to do something better in .NET 8. I think they have achieved something in here. For the past few years, they've been keep reducing the size of the application. So we don't need the framework now. We can just create a standalone application. But initially, it was huge when you compare it to like megabytes and megabytes of data. Now I think it will be quite cool when you have a little application, just sit and just open somewhere and play it.
true.
Startup times are interesting too. I think that's
Yeah, for sure. All right, I think we have another, like, I'm super excited for this, but yeah, I'll let you speak.
So I think someone Kalinga mentioned we forgot OpenTelemetry. No, we did not. It's existing with .NET 7, of course you could, but then with .NET 8, it's so much easier. So OpenTelemetry is basically a cross-platform open standard for collecting and emptying telemetry data. So it's a platform agnostic standard. So it supports .NET, Java, and so many libraries available for that standard. So a lot of the support this standard do understand language in terms of how logs are shaped, how metrics are shaped, and so on. So it's really easy to plug in and plug out things. So this is just an example with Prometheus. There's a lot of extension methods. So basically, with your application and the OpenTelemetry SDK, you could expose a Prometheus as the default /matrix endpoint. So Prometheus would pull in data from it, and then you could use Grafana to visualize that. So if you just move into the next slide, Surya, it's just this bit of code that you need to write in your program CS file. be using the different extension methods that come with the OpenTelemetry Matrix API. Of course, this is for Matrix, but then there's the same for tracing. So you can use tools like Zipkin and so on for tracing as well. And it exposes a scraping endpoint, and then what you can do with that is if you connect it with if you connect Prometheus with Grafana, when we move to the next slide, it's going to give you out of the box really good HTTP and network stack metrics like response time, scores, and so on. Just to add another thing, I think HTTP 3 was supported with .NET 7, and it's kind of fully supported with .NET 8, I think, which is really cool. Yeah, so that's something to look forward to as well. This is one of the exciting features coming with .NET 8. I'm quite looking forward for it. And I saw a tweet from one of the program managers for .NET that they're itching to sort of also ship the dashboard by default. So when you sort of run a .NET Core application and you set up the metric in your program series, you're going to have dashboard by default. You're going to have auth by default, and that is really, really cool if they go ahead and do that, because now then it's so much easier to build cloud native applications. As of preview 7, which was out a couple of weeks back, I think that was not, I didn't see the announcement, but then at least this is out, and this is really cool.
Yeah, I mean, like already now on Azure, looking at the dashboard and looking at, oh, what failed, and so if it's shipped in, that's amazing. Yeah, this is pretty cool. All right, so I guess what I'm hearing is basically it keeps getting better, right? I guess as the evolution and the ecosystem, it just as time goes on, it keeps getting better, and it makes building cloud applications more simpler, I believe. I don't know, I love .NET and I think it works for me, but does anybody want to, I don't know, do you guys want to give your final thoughts on how .NET helps in building cloud applications?
Yes, I think there is one area we could not cover because of time restrictions. That's resilience. And I saw with .NET 8, there's more support coming in with extension methods that you can, out of the box add resilience. So it's going to retry some of your API calls and apply patterns like circuit breakers and so on. Of course, you can do it as of now with Poly, but that's really cool. So basically, if you look at .NET today, it has a full 360-degree in terms of features to build cloud native applications out of the box with zero dependencies. With .NET 8, that's coming. So it's really cool. And with Microsoft's backing, I think .NET is going quite well. And even in the recent Stack Overflow developer survey, I noticed something that compared to last year and this year, .NET has jumped up in the preferred frameworks. So that is quite interesting. Yeah.
Vankita, any final views?
No, I think we pretty much covered everything. There's a lot to be covered in the .NET area when it comes to the cloud native with Azure. We try to cover as much as possible, but I think we missed a few things. I think one of the things that we should really mention is the orchestration, how the Kubernetes and stuff are like helping us to manage the Dockers inside the applications. I think we can get into that some other day when we do another presentation.
All right. Yeah, for sure. I know like I mentioned, the cloud is so vast and .NET as well. So we couldn't cover all. I know there's so many important topics. And we could have an hour chat on identity or scalability or serverless. For example, I know there's containerization and so many more cool topics. So we'll definitely jump into those in our follow-up sessions. But for the time being, does anybody have any questions? I'm sure Lankita and Rifan will be more than happy to answer them. But let's check if there are any questions in the chat or Slido, I guess. Let me see how there's a slide. I mean, you guys can scan it and maybe drop in your questions if you have any. See. Do we have any questions in the chat?
So while someone posed a question, I think, Irfan, I think we should really mention about the data sharding in the cloud when it's come to the huge databases. And I don't say that it's one of the best solutions that we can go for. I think we had a discussion there some other day earlier. I think one of the it's kind of the last solution, as you mentioned, when someone can go for. But I think the cloud supports it, and since we can use it for applications to like divide the data into multiple sections and just read as fast as possible. What do you say, Irfan?
Absolutely. Yeah, of course, one of the last things that you need to consider, because SQL Server going relational and SQL Server, it's more than capable of running most applications. I remember I read an article from one of the architects at GoFlow. They did run with a single instance for a long time with SQL Server until they had to actually approach with sharding. So it's a good approach, but then it's one of the last solutions that you want to touch because it adds a lot of complexity. And when you get to that stage, no longer your usual, auto increment primary key is unique now.
Yeah, it's not cheap. It comes with a lot of joins and everything, and so if the company is super massive and your data is like millions and trillions of records, then I think that might be the time you think you should consider about it.
But application separation might come before that. Not exactly microservices, I don't know, like.
Yes, true.
But then just separating your application, if you could, into 2 parts or 3 parts, depending on how it is, and then slowly evolve. So microservice also is not like an upfront solution. Start something, you don't directly go with microservice without understanding the domain and the complexity of the domain and so on.
Yeah, I think basically we should all start with monolith and slowly convert to something else, right?
If it's a new one, yes. Let's keep it simple.
All right. So I have a question. Someone's asking, what's the advantage of Blazor and WebAssembly over VS? Is there any advantage, or like, I personally think it's your preference.
Yeah.
Can you repeat the question again,
So what are the advantages of Blazor and WebAssembly over JavaScript?
It's a really good question. Well,
personally for me, I think, I'm not a front-end developer, I'm a back-end developer. Blazor is in C#, right? There's like Blazor server, obviously Blazor WebAssembly, but it's just your comfort and you can get the same thing done. I've done Angular, but not really React. So it's easier for me to do Blazor, and I don't see any disadvantage. So that would be my take on it. But yeah.
And it's still evolving. I think Blazor and WASM versus JS. So not sure how it's going to be. But yeah.
And I think that the Blazor really support the server-side rendering, and I think over the years they have improved the performance as well, not like the initial stage. And it does have a lot of tools involved. And I think with the recent versions of .NET, we can build Blazor MAUI applications as well, like which is cross-platform, multiple OSs can have it with a single installations. So yeah, I think Blazor is kind of cool thing to know, but it's not good for all the time.
Yeah.
We also have sorry, were you saying something, Rifan?
No.
Okay, we also have another question from Sarah. She says, for a small project at the beginning, which cloud provider is more cost effective? Is it Azure or AWS? And I think that's a really biased question. I would always go for Azure, but I'll let you guys answer.
I don't know. It depends on the project and what service and how you're going to set it up. One is fine. So it's really hard to say. Yeah.
Do you think there is a cost? Because I've heard this quite often that Azure is very expensive. Do you think there is a big difference?
Personally, I've worked with AWS before a lot for Azure. The free tier bandwidth in AWS is really good. I wouldn't say compared to Azure. Yeah, you could say that arguably. You could argue either way depending on what application you want to set up. But if you are in the Microsoft ecosystem working with .NET and so on, Azure would be really easy to get started with, really intuitive.
Yeah, that was how I was going for, like Visual
Yeah,
Studio.
I think both comes with both the environments comes with free tiers. I think the Azure comes with $200 free tier, and it's AWS, as I remember, 1 year free subscription. I might be wrong, but so with that given time period, you can decide what is the good for you. And also, the board supports the pay-as-you-go structure. So whatever you need use, you can pay for that. And also, I think in Azure and also in AWS, there are cost management tools, and you can and also cost calculation tools. You can just go and select the server, so the services that you need, and select them and get the cost calculation according to it. So it all is based on the needs of your needs. Actually, you can just go for both calculators and check what is better for you or your need.
Yeah, and when it comes to a small application or small project, you're focusing on the functionality more than the things that you have to do in terms of infrastructure and so on. So the easiest thing would be to do is to open up, if you're building it in .NET, open up Visual Studio, connect and probably directly deploy it to app service and just get it running if it covers the cost. Simple as that, nothing complicated. And then you can build on top of it as you go.
Yeah,
I think, Surya, the best thing to do is list down your requirement and estimate the usage, and then go for the calculators and do the calculation, see what is best for you over the years. So it might be for 1 month usage, it might be there can be a huge gap, but if it is like 1 year, 10 years of usage, you can see kind of similar payments for both things.
All right. Cool. Do we have time for one more question? I see someone said, do you recommend any remote development tool for Kubernetes?
I'm sorry?
Sorry, in the chat, there's a question. Do you recommend any remote development tool for Kubernetes?
Remote development for Kubernetes. Go ahead, Lankita.
Oh, no, nothing comes into my mind.
No, sorry, I don't work much with Kubernetes. Like I said, might be an unpopular opinion, but I think, I don't know, 80% of the applications out there or 90% of the applications out there would be just fine with any platform as a service thing. But yeah, I extensively work with Kubernetes.
As I remember, I think the Visual Studio Code does support remote development. Yeah, I think yes.
It works well with Docker Compose, I know. So you could have your entire application with Docker Compose and then work on top of it. But then K8, no, not sure.
Yeah.
Okay, I think we've just hit time. It's 6 o'clock, and I know it's work day. Everyone's probably just done with work and ready to go home. So I'm not going to take a lot of your time. I think there's a poll on Slido that you can use to, I don't know, rate this session if you like it. We will obviously be doing more sessions to cover up all the cool concepts. But yeah, that's about it. Thank you so much. Thank you, Rafan, and thank you, Lankita. Thank you for taking your time. I learned a lot. I hope everyone did. But thank you guys. It's been great.
Okay.
Thanks, everyone. Yeah.
Thank you. And I hope everyone joins the next session.
Yeah.
All right.
See you on next session, guys. Thank you for being here. Thanks, guys.
Thank you.